Let's carry on with the file from our previous example, and we want to explore a finishing toolpath so we can focus our attention on a certain area. To get started, I'm going to hide the last toolpath. That way I don't see it on the screen, and I want to make sure my insertion point is below it. The areas that we want to focus on are going to be these three faces that are cut at. To do this, we're going to explore the 3D Spiral Toolpath. I'm going to adjust the stock to leave on the wall and floor to 0. And then I want to select the faces that I want for my machining regions. And that'll be these three faces here, and then we can end the selection. I also want to include an avoidance region or avoidance face, and it's going to be this bottom face. This will help ensure that the tool doesn't come down to the bottom of these and actually gouge into solid geometry. Next, we want to talk about toolpath control. I need containment boundaries. And to do this, I'm going to be using the solid chaining option, and I'm going to be selecting these regions over here. Now, I want to make note of the direction the green arrow is pointing. As I select each of these faces, if I need to, I'm going to reverse it to make sure that they're all going the same direction. So again, all three of those regions, those are going to be my containment boundaries. I'm going to contain the tool contact point, not the tip, because we are dealing with faces that sweep up at an angle. I want to make sure that we're not dealing with just the tip of the tool, but actually where the tool contacts that surface. The tool that we want to use is number 11, the 3/8 ball end mill, and I'm going to comment this as Spiral Finish. The reason I'm adding these comments in is because they're going to be displayed inside of my Toolpath Manager, as well as being displayed directly inside of the code that we post. So my comments are very general and related to the toolpath that we're using, but yours should most likely be something that represents the area you're machining or a specific feature. I'm going to skip over stock because we're not worried about any stock model or any remaining stock from previous operations. We're telling this toolpath exactly where we want it to cut and what to avoid, so we don't need to worry as much about material that's left behind. I am going to increase the step over value. Anytime I'm making a new finishing toolpath, I like to increase that value and make sure that I'm not calculating a large number of steps. This helps speed up the toolpath creation. The next thing that we need to do is we need to select a center point. Because this is a spiral toolpath, it wants to know where the radius or where the actual center of that arc is. So we're going to be using our auto cursor option, selecting arc center, and we're going to grab this edge here. We're going to leave our transitions and steep and shallow and all of our linking parameters alone for right now and say OK and allow it to calculate this toolpath. There are some instances such as this where when we create a toolpath, nothing displays on the screen and we need to do a little bit of troubleshooting. I always like to work my way back to the model geometry to make sure that's selected, then go into my toolpath control and make sure that all of these chains are pointing the appropriate direction. In this case, I'm going to change sides, so that way those small arrows are pointing inside. I'm going to regenerate this and see if we have any toolpath that's been created. So again, you can see that we're still missing something here, and if we go to cut parameters, we can go back to the arc center point, and instead of getting the actual center point of this arc, I'm going to actually go to the midpoint of this line, allow it to calculate, and see if we can at least get some passes on this toolpath. So what we're seeing is it's actually arcing around that point. So the toolpath is working, the containment regions are fine, it just needs a better reference for that arc. And as soon as we select that arc again and allow it to recalculate, we're now seeing what we would expect to see, that arced toolpath. We can see also on the screen a lot of yellow, and this means that we have a lot of rapid movements. To minimize those, we can go to our linking parameters and we can reduce our clearance plane. I'm going to set this to 0.05 and change this to minimum vertical retract and recalculate it one more time. So now you can see we're not wasting as much time with the tool going really above the part, but this allows us to get to a situation where we're cutting these based on the arc of which they were originally designed, and we're using that spiral toolpath to get the best surface finish possible. Through some validation with Verify, we'd be able to see if the scallop step over is enough, or we can do that with some calculations based on the tool diameter. But for right now, I'm going to leave it as is with 0.035 as my step over, and make sure that I save my file and move on to the next step. Let's carry on with the file from our previous example, and now we're going to talk a little bit about 2D contours to finish off certain areas of the part. I'm going to hide the Spiral Toolpath, and I want to focus in on this pocket up here. We have a few step locations, and we're going to have to go back over them with the bull end mill and clean this up. So the first thing I want to do is go to my 2D Contour Toolpath. I'm going to be using the edge, and I'm going to select this bottom edge of the opening, and notice that it grabs the full chain for us, so we can say OK, and then we can OK this chaining dialog box. Notice the toolpath types that we have available to us. We have our contour, our pocket, the dynamic facing, which we've already used. We have a slot mill toolpath, which is designed specifically for slot geometry, and then we have a model chamfer, which we'll explore here in a little bit. But right now we're going to be focusing on the contour, and the tool that we want to use is going to be our 1/2" bullnose mill. And we're going to contour upper pocket. Now remember originally that this geometry actually had a fillet on the corner, and we're just going to be using the radius that's on the side of our bullnose mill. So we don't have to worry about any specific offsets or anything like that. We can simply come in based on the selections that we have. For the cut parameters, we're going to focus our attention specifically on the opening right now. We've already gone through and we've used the OptiRest to clear out most of this material, so there's only a small amount left. So we don't have to leave any stock or worry too much about roughing this pocket out. We just need to come in and do a finished toolpath. We don't need to worry about depth cuts, and we have our lead in and lead out values that are, in this case, 100% by default, and these are going to be too large for us. So we're going to reduce these to 0.05. For the radius value, which is currently set to 100% of the tool, we want to reduce that as well, and we're going to take it down to 20%, and then we're going to push those over to the exit. We're not worried about breakthrough or multi-passes or tabs, but we are going to go into our linking parameters, and we're going to offset a small amount from the bottom. So the depth is based on our selection, and we're going to use minus 0.08. Now the radius on the corner of our tool is 0.06, so using 0.08 will allow us to extend a little bit past that. I'm going to say OK and allow it to generate this path, and notice that it's not in the correct area, and that's based on the compensation. There are two things that we need to consider when we talk about compensation. The first of which is the chain selection itself. So if I right click on this chain and change sides, that small arrow is going to be pointing inside, and this is the area that I want to cut. So if I regenerate the toolpath, now we have the cut located in the correct place. In our parameters, however, if we go to cut parameters, we can compensate to the left or the right of the curve or the entity that we selected. So in this case, I simply flipped the chaining geometry, and that worked for me. Now what I want to do is focus our attention on the two small steps. So at this point, we've already cleaned everything out up to here, but we need to go back and we need to take care of these edges as well. So I'm going to do another 2D contour, but this time I'm going to select this edge, but notice that it automatically grabs the entire thing. So I'm going to undo that selection, and I want to make sure that I'm allowed to use partial edges. So we're going to be using the edge option, the first option here, and then we can select an individual edge. I'm also going to select this one up here, but also note that we've got some additional areas that we can select here. And these are going to be important because we're going to be using some options to extend the entry and exit. So we want to select this, and I'm going to reverse it. So I'm going to flip the direction, then I'm going to work my way around. We can also click on the red arrow to extend the tangency of our selection. Now I'm going to make another selection up here, and again I'm going to reverse it. I'm going to work my way around. And once I have all of those, I can say OK. So now I have those two different chains that I selected. I'm going to continue using the bullnose mill, and I'm going to call this one Contour Steps. For my cut parameters, I want to take a look at some of my options. So we're not leaving any stock, of course. We're going to keep the same compensation that we had before, but we do want to take a look at the lead in and lead out options. So the lead in and lead out options allow us to dictate how long of a section we're going to be arcing in, and potentially how long of a section we're going to be going straight in. So if we work through some of these options, you'll notice that we have tangent or perpendicular. So the tangent or perpendicular is going to be based on the entry and the exit. So you can see here that we have a graphics that changes every time we change that radio button. So we're going to be using the tangent option, and then notice that again we can modify the radius. And then there are some options at the bottom that call for adjusting the start or end of the contour. So I'm going to add 25% or 1/8 of an inch, and I'm going to extend it. And then I'm going to push that over to the exit, and I want to extend the exit. The linking parameters are going to be based specifically on the depth of our selection. I'm not going to extend that down any further. So I'm going to say OK, and then take a look at the results. With those selected, I'm going to backplot them to see where the tool is on screen. So we want the tool to come down, and notice that it's starting before the edge. So we want to start the cut before that edge starts. It's working its way in, comes into the contour, goes out, and then it raises up and it repeats the process on the upper step. So we're not leaving any stock. We are extending the entry and the exit, so that way we're getting a nice smooth transition, and we're still arcing into it. So this allows us to clear out those areas, and a good final check of this is for us to create a stock model based on everything since the last stock model we created, which was drilled holes. So I'm going to create a new stock model, and this one is going to be called upper pocket. Again, we need to reset our stock plane to make sure that we're using the top plane. This is the original one that our stock was created with. We're going to go from drilled holes, and the source operations are going to be everything after that drill hole stock model. If you have any trouble remembering which operation that was, you can take a look inside of here and you can see that we're skipping number 7. We can also move this on the screen and we can see that stock model is operation number 7. So I'm going to control select 8, 9, 10, and 11, and 12. And then say OK and allow it to create that stock model for me. You can see that we have the multi-threading manager displayed, and again we can go to view and we can turn that on and see the progress of, in this case, completing the stock model. With the stock model complete, we can now take a look at the results of this pocket. So you can see that we've cut it deeper than it needs to go, obviously, because we're focusing in specifically on our model. And you can see that these corners do have the nice rounded edges that we were expecting to see. If we want to get a better idea, we can also hide the chain guard and take a look at the geometry that we have. This rounded corner here is the difference between the stock to leave from our OptiRough operation and the finishing pass we used with our bull end mill. The reason we see that is because we didn't cut down to that final edge. However, once we go past this specific point should be 0.08 or 80 thou past the bottom of where our actual part is. So we can also see that here that we do have some extension past the bottom of our part. So the process of creating those contours is the same one that we're going to do to finish off this face, as well as these steps and the steps on the back corner here as well. So we can see that these are rounded, but that's simply because of the bull end mill that we use to rough this area. But we still need to go back with a contour toolpath and clean those out to the final shape. We can also see from this stock model that we need to decrease the value for our step over on the spiral cut. So there's still a lot to do on this specific part, but this is a pretty good spot for us to stop right now. So let's go ahead and make sure that we save the file before we move on to the next step. For this next lesson, we want to start with a supplied dataset, Chain Guard Setup 1 Chamfer. This is a similar file to the one we've been working with. However, there are some additional 2D contour operations that go back through several areas and clean things up. From here, what we want to do is we want to focus on chamfer toolpaths. And to do this, we're going to get started by expanding the gallery and selecting our 2D model chamfer toolpath. We're going to select chain geometry, and using the option to select a closed chain, we're going to turn off the face option. We're going to start by selecting this upper edge, and we'll select this one as well and say OK. It's always important for me to note the direction that the contours are going. This is going to be important because it determines which compensation direction we're going to be using, especially if we're focusing on climb or conventional cut. And the model chamfer toolpath allows us to check against solid geometry. We can also manually select an avoidance model if we wish, specific surfaces that we need to stay away from, but in this case we're going to be checking directly against the entire solid model. For our tool, we need to use a chamfer end mill, so we're going to select tool number 2 and add a comment for chamfer. Under cut parameters, we need to define what the chamfer width is going to be. In this case, we're going to use 0.01 or 10 thou. Also note there's a bottom offset value, and this is how far the tool is going to extend down below that chamfer edge. We don't need to worry about depth cuts or multi-passes in this case, but we do want to double check our lead in and lead out. These parameters oftentimes populate from previous operations. So just come in here and make sure that adjust start of contour and adjust end of contour are both turned off, as we have used them in previous operations. Then in linking parameters, we don't need to make any changes, but I want to note that it looks different than something like a 2D contour toolpath. We'll say OK and allow it to create those toolpaths for us. Notice that one is created and the other one is not. This is usually the case based on our geometry. You'll notice that the one on the left, the small arrow is pointing inward of the contour. However, the one on the right, the small arrow is pointing outward. So if we go into that loop and we change its side, notice that it's actually changing both of them. I'm going to use this opportunity to rechain all. I'm going to select this edge, and I'm going to make sure that the arrow is pointing this direction, and I'll select this edge, and I want to ensure that its arrow is also pointing that same direction. Notice they're both pointing outward, and if I change sides, they'll now both be pointing inward. So it's a good on-screen indicator to ensure that the green arrows when you select your chains are pointing the same direction. Let's go ahead and regenerate this toolpath. Now we can see both of those contours on the screen. This file also does contain an additional stock model called Upper Pocket, and inside of our simulator options, the stock model Upper Pocket is selected. So if you want to validate this, we can select the operation and then go to Verify. This will preload the stock model and allow us to check against the stock model for all previous operations without having to run through each of those options. So if we play each of these forward, we can zoom in and see that we've taken a small cut on the edge of both of those pockets. This is what we were expecting to do, just a small edge break toolpath. We want to apply this toolpath one more time just to make sure we understand some of the options that it contains. So again, we'll come in and select our chain geometry, and this time we want to make sure that we use the edges option because we're going to be selecting an open contour. So we're going to select this, and then we're going to carry it one extra step to make sure we're getting the straight edge all the way up until the drop in height along that edge. So we're going to select those two and say OK. From here, again, it's checking against the solid model, and I want to make note of the side clearance value of 0. I'm not going to make any other adjustments. Say OK and allow it to generate that toolpath, and then I'm going to use the backplot selected operation option. I'm going to roll this forward until the tool starts to engage, and I want to make note of how close the tool is to the solid model. There's no clearance between it. So if this side of the wall has not been machined all the way down, we would have a collision with that edge. In order to correct this, we need to go back to our parameters, and on the toolpath type, we add a small amount of clearance in the side clearance box next to solid model. We'll regenerate this, and once again, we'll backplot it so we can see the tool on the screen. Now if we take a look at this, we should have 20 thou clearance between the tool and the part. So this is a great way to create these chamfers, especially when you're up against edges of parts and you need that additional collision checking to apply that clearance value. But what if we wanted to take a look at deburring this entire edge around this pocket that goes between two planes and has a change in elevation? In order to do that, we would want to take a look at a deburr operation. Now this is a multi-axis toolpath, so we're not going to cover it in depth, but I do want to select it, and I want to make sure that we understand some of the options. I'm going to be selecting tool number 11, our 3/8 ball, and if you don't have access to multi-axis toolpaths, just watch the video so we can understand the options that we have. I'm going to skip cut pattern for now and take a look at the tool axis control, and note that even though this is a multi-axis toolpath, we can use it for 3, 4, and 5 axis toolpaths, as well as 4+1 and 3+2. We're going to be using it for 3 axis. we're going to go back to cut pattern and we want to change the auto detect option to user defined. So notice this changes from excluded edges to user defined edges. So we're going to select the edges that we want to cut, and I'm going to start with this edge here and use the option to go to next. And it's important to note that the red arrow is going to be the direction of next. If we want to change, in this case switch the branches, we'll use the adjust option, then we'll work our way forward. Once we get all the way back around, we can say OK. I'm not going to make any changes to this because it gives a consistent width edge shape automatically, and I'm going to say OK. Notice that it tells me that I'm missing the machining surfaces. So I want to select those machining surfaces, and in order to do that, we'll go to Part, and I'm going to triple click the model to select the entire solid body, and it'll use that as a check. Once this generates our toolpath, then we can go ahead and use backplot again and take a look at what it's doing. Now again, we're using this with a 3-axis option, but we can see that it's allowing it to roll around all these edges and do a quick deburr on this complex part. So this is where something such as a 2D contour with the chamfer option under cut parameters, or using the model chamfer option, is not going to be able to traverse the model and be able to cut all of those 3-dimensional edges. But again, the deburr toolpath, even in its 3-axis form, is only available if you have access to the multi-axis toolpaths. From here, I'm going to remove the deburr toolpath, and I'm going to go back to my view sheet bookmark by double-clicking on Op1, and then I want to save the model before I move on to the next lesson.